Today I'm going to talk about room modes and specifically about a software called RoomSizer from RPG that we usually use in our company to predict what is the best room ratios and dimensions for optimal room response. So I'm going to run this software from the start. So the first thing that you need to do probably is change either to metric or to the imperial units. Since I'm in Europe, I'm going to use metric units. You can also display the colors and other information, the grid, etc. So I'm not going to do this. Then I'm going to start with the configuration of the room. So edit configuration. And in this box over here, I'm going to enter the dimensions of the room. Not quite the dimensions, but the possible limits of my new room. So I'm going to hit OK. And so what the software basically enables me is to pick up different dimensions from for the length, the width, and the height of the room. I can specify the smallest amount, the biggest amount, and then the software is going to calculate what is the ideal room dimensions with the best frequency response. Keep in mind that this is only working for low frequency. So I'm testing this probably between 20 Hertz and 200 Hertz. So let's imagine that I want to build like a control room, like a large control room. So I'm going to probably start with 5 meters and maybe my longest dimension will be 8 meters. Now the width, I'm going to narrow a little bit, 4 meters, and the longest maybe 6. And the height of the room, maybe 3.5 as the minimum and 4.5, okay? So I'm going to hit OK. And now, as you can see, the software is calculating the different possibilities. So it's searching for different values over here. So the pink line is the worst scenario. The yellow line, it's the best scenario. So it's doing this kind of possibilities, and then it's going to present me what are the ideal room size for these specific limits that I have chosen for. So it says the optimization has finished. I click OK. And as you can see, best solution found. It says the room dimension should be around 7 meters per 5.8 meters width and 3.8 meters height. Okay. Now, the good thing about this software, and that is something that usually most room mode calculators don't have, is that it also enables the implementation of absorption in our model. So usually what happens is that if we place absorption inside the room, it's going to shift the peaks of the room modes of our space. So for the exact dimensions, if I have, for instance, 10% of absorption, which is 0.1, I have a certain peak modes and certain values in my frequency chart. If I have a finished room, for instance, 19% of absorption, then it's going to shift the frequency response of the room. So I can actually play with the software and deal with that information. Not even that, for instance, I may have two different reflective rooms. For instance, if I have a room with concrete is very reflective, probably 1 or 2%. So it's 0.01 or 0.02 of alpha coefficient value. But if I have my room finished with plasterboard, then it's not 1 or 2%, maybe it's around 10%. So these small differences may actually have some impact in my room. And I can do this in the software actually. So I go to advanced. Okay, frequency range is the frequency range for my software. I'm going to leave it like this. and then I have advanced room absorption, okay? And in this place over here, I can specify the coefficients even of the different areas of the room. So let's say that my front wall is absorptive, is full with absorption. So maybe this is 0.9. And the left wall, so let's just play with this just for fun, 0.6, just for 0.6, and let's leave the floor, and of course the ceiling also. So let's leave the rear wall and the floor reflective. So if I hit OK, and now I'm going to run, I'm not sure if this is going to change that much the dimensions, but they are surely going to be different. So if I hit start, now it's going to run the software again. So it's already running. So it's doing all these calculations over here. So actually now the suggested dimensions are different under my limit. So it's 6.1 meters length by 5.1 meters width by 4 meters height, okay? Usually what happens with the software is that every time that I run the software, it will probably give me different results. So if I quick actions and it start again, it's going probably to give different approaches. Let's see. So this one is these are slightly different dimensions. So usually what I do, I run this a couple of times, maybe 5 times or 10 times, just to pick up different variations of different possibilities for the room size and the room ratios, and then I probably just pick the ones that occur the most. Then we have something very important with this, which is the room response calculation. So the software, it actually enables us to place absorption in our model, but it also creates something very unique, which is it calculates the overlap between different modes, and it tries to smooth out the frequency response according to the overlapping of modes. So if I read it on room response calculation over here, I have different models over here. So frequency-based model calculation is the usually normal calculation that we can do in an Excel spreadsheet. There's no dependence from the reflections from the walls to calculate our room. So I never use this model. I usually only use the time-based model calculation. The number of reflection orders is the number of times that the wall is reflected on the number of times that the sound is reflected in our walls and the ceiling, and that all that information is going to create our room response and our low frequency behavior. Usually I set this as 15, which is the default value. And then we have this over here, which is the number of samples in moving average used to smooth model spectra. So this is what I'm talking about. So the frequency response is smoothed, because usually what happens is that these huge peaks, they actually do not occur in real life situations. So the program has that specific aspect in consideration and tries to smooth the model spectra values, so I don't get like weird frequencies peaking at weird values, okay? Usually I also keep this at default. I usually keep this at 3. I don't change it as well. So I go here and of course I can run the software again. Of course I can change I can view different information over here. So this is a spectral frequency in real time. It's calculating different model responses. You can see this is the different room ratios over here. And this is the different room modes over here. So this is length, width, first order room modes, and then we have the second order room modes, etc., etc. Let me run it again so we can use different. So this is data. Okay, this is data. This is the normal view. Okay, view and configuration. Okay, this is the configuration of our room. So the limits that I set up with. So I usually keep this with the normal configuration, which is the this is a room view. Okay. Usually I work this way with the 4 windows open. I think it's better to move. Also, keep in mind that our model is actually placing the loudspeaker at the corner of our room, and then it places the listener at the opposite of that specific corner. So over here we have our loudspeaker, as you can see, and then we have our listener over here. So this is like the worst case scenario. This is not what happens in the control room, because we have the speakers away from the walls, and our location of the listener is also not on the corner. So what happens in this case is that since we are close to the wall, the sound pressure is very high, and we have like the worst case scenarios for this kind of rooms. I'm not sure if the software actually enables me to change the location of the speaker. I don't think so. Usually what happens, let me see. No, it just enables me to change the dimensions of a room, and then we of course calculate the worst case scenario for those specific dimensions. So it doesn't change the location of the speaker and the listener. I think this is very high-end definitions that I usually don't work with. I usually can at least maybe try to seek different solutions for the room. Okay, and that's it. There's no more information over here. We can print the information, we can export to an image, and that's it basically. Okay, thank you for watching. I hope you have enjoyed the video, and stay tuned for further uploads, and don't forget to subscribe and hit the like button. Thank you.